Okay, MCT4C, lesson 1.1, part 2. We just talked about some special angles and their trig ratios, and now we're going to essentially find exact values of multiples of 30, 45, and 60, and so on. And how we're going to do this, actually, we're going to place this angle, a rotation angle, on an XY grid. So to discuss angles other than acute angles, we place the angle theta on an XY plane. We call theta, and I let the cat out of the bag there a little bit, it's called a rotation angle. Just switch this so it's a little smaller. There we go. One arm of the rotation angle is on the positive x-axis. We always start there on the positive x-axis, and then the angle rotates out from there. The other, this arm, is called the terminal arm. It's labeled there, but we'll write that right here, terminal arm. Rotates counterclockwise through the four quadrants. So, you know, this is a rotation angle of 0 if this arm was there, and then it rotates through. Let me see if I can just do this. It'll mess up my diagram a little bit. No, maybe not. But it rotates this way from the first quadrant to the second quadrant to the third quadrant to all the way around. And then we can start talking about trig ratios of any angles. The acute angle, alpha in the diagram, that the terminal arm makes with the x-axis is called the reference angle. Reference angle. And this reference angle is always to the x-axis. So when the terminal arm is down here, it's always to the x-axis. So we'll be in here. We'll see this in a bit. The reference angle in some other textbooks is sometimes called the related acute angle. And I'll probably let that slip once in a while because I like calling it the related acute angle too. Related acute angle. I short form that to RA. The reference angle I often call the RA. All right, we got an example here maybe. Draw a rotation angle of 210 degrees, state the reference angle, then state the sine of 210, the cos of 210, and the tangent of 210. Okay. All right, well, let's, and this doesn't have to be exact. We're just going to do a sketch. Well, there's the xy axis, right? That's not very good. Get rid of you. Straighten you out. And we're going to be ready to go here. So 210 degrees, remember the one arm will start here, so I'm going to maybe draw that here. There's the one arm, and of course that, we don't usually write that one there because it's always the positive x-axis, and then it rotates out, right? If the second part rotated to here, well, that would be a 90-degree angle, right? 90, 180, and then 210 is a little bit more than that, isn't it? But it's not this much because that's 270. 180 plus 90 is 270, so it's in here somewhere, right? And then this angle, and I'm just guessing. I never got out a protractor or anything like that. That angle there is our 210-degree angle. Well, if that's 180 to right there, how much is this? Well, it's 210 subtract 180, isn't it? 210 subtract 180. And there's our reference angle, right? Our reference angle is one of our special angles from earlier in the lesson, isn't it? And so, if we wanted to, what we could do, it's not very straight, but we could set up one of those triangles from earlier in the lesson. Where was it? This triangle here, right? The 1, 2, square root of 3 triangle on our xy plane, right? So 30, well, that's 1 here. This is square root of 3, and this is 2. If I look back on those triangles from earlier. But notice that since I've gone left, this isn't just the square root of 3, this is negative square root of 3, right? Because it's to the left. Similarly, I've gone down here, so this is minus 2. We always think of the hypotenuse as being positive, so this isn't minus 2, but we can see going left, this should be minus, and going down, this should be minus. And so now, if I wanted to, I could state these trig ratios. The trig ratio sine of 210 degrees is still just sine is opposite over hypotenuse. Opposite is negative 1 over hypotenuse, which is 2. The cosine then of 210 degrees, adjacent over hypotenuse, and notice exact values, negative square root of 3 over 2. And the tangent then is opposite over adjacent. Opposite's negative 1 over negative square root of 3. You can simplify that a little bit, I suppose. There. And that's all we were asked to do, right? A was the diagram, which we did. And the reference angle, I suppose we could have done a better job answering that question. Alpha was 30 degrees. And for today, at least, this reference angle will always be one of our special ones, 30, 45, 60, so on. And then part C is down here, I suppose. Right? Dandy. Let's keep going. All right. This diagram is another concept that comes in handy when we're talking about these trig ratios. It's called the unit circle. We see a circle, and since the radius is 1, we call it the unit circle. And notice that if this is the point xy, that means this is x, isn't it? And this is y, right? And the hypotenuse is 1. X, then y. And if I wanted to, then I could write the cosine of theta. Well, the cosine of theta is adjacent over hypotenuse. Adjacent over hypotenuse. Well, that's just x, isn't it? X divided by 1 is just x. Similarly, if I wanted to find the sine of theta, it's opposite over hypotenuse, which is just y. Y divided by 1 is just y. And so then, when I have a point here, the x-coordinate is the cosine, and the y-coordinate is sine. Tangent of this is just opposite over adjacent still. It's a great opposite over adjacent, y over x, if I wanted to know that. Y over x. It says the unit circle explains the trig ratios of 0, 90, 180, and 270. We used our calculator, but we were supposed to, using these exact angles, we were supposed to not use our calculator. We're supposed to pretend that we didn't have a calculator available to us. But so how does that explain that, the sine of 0 is 0 and the cos of 0 is 1? Well, that's not very good. Oops. I'm just going to draw a little unit circle then. Kind of messing around here. Unit circle. Draw a unit circle. So here's a unit circle. And if I had a 0-degree rotation angle, and then this is the point that I'm talking about, xy. And this is the point 1, 0, right? That's the coordinates of this point right here. Well, the x-coordinate is the cosine. So that's the cos of 0. And this is the sine of 0, right? Similarly, and I won't do all of them, but let's do 270, say. That's not very good, but we'll get the idea. 90, 180, 270. There's the rotation angle. Right? There's the starting arm, there's the terminal arm, and there's the point. Well, what's the coordinates of that point? Well, we don't go left or right, so the x-coordinate is 0, and the y-coordinate down 1. And so that's the coordinate of that point. And now I can see the cos of 270. Cos is x, the x-coordinate's 0. And the sine 270 is negative 1. Oops. And go ahead, you can check that on your calculator. I'll wait for you. No, I won't wait for you. Let's move on. So find the primary trig ratios for a rotation angle of 315. This is similar to a question that we did earlier, but we're sort of on our own to figure out how to do this. The number one thing is to get a diagram. Figure out where this 315 degrees lines up, because then we can get an idea of the rotation angle. So I'm going to start with, there's my starting line, and now where's this going to end up? Well, there's 90, 180, 270, 360 would be all the way around, so it's somewhere in here. This is the rotation angle, all the way around there. We're going to say that's 315. And of course, the big thing is to figure out what the reference angle is. The reference angle will give us the side lengths, right? Well, what's 360 subtract 315? It's going to be one of our special angles. It's 45, isn't it? So this is 45. All right, well, that means we could build that 45-degree triangle, that triangle there. That's not a very good side, but that's supposed to be straight. Let me just fix that up real quick. Why not? And so what are the side lengths? Well, this is the square root of 2. That's 1 and that's 1. Now, which of these coordinates are positive? Well, we said the hypotenuse always is positive. When I go to the right, that's positive. But when I go down, that's negative. So now, if I want to do the sine cos and tan of 315, I can just read it off of this triangle now. So sine is opposite over hypotenuse, -1 over the square root of 2. Cos is adjacent over hypotenuse, 1 over the square root of 2. Exact values, right? Exact values. And tan opposite over adjacent, -1 over 1. -1. And that's it.